very pleased to be with you all today to talk about OSG at Arizona State and to be mindful of the fact that I'm the only thing between you and the break. So I'll try and be compassionate in that regard. So first, we'll talk briefly about ASU and then briefly about research computing, the group that I lead. I'm Senior Director for Research Computing at ASU. At ASU, I think I get paid $1 every time I use the word innovation because it is in our blood. And the first bullet point on the slide talks about ASU positioning itself as the new American university. That means we have a lot of students, and you can see the numbers there, including online learners, in-person learners, and many different learning modalities. A lot of faculty, a lot of employees, and several campuses, both in Arizona and a few around the country and nationally. Specifically about research, we do a lot of research. Ranked among universities without a medical school, public universities, we're number 6 and have about $670 million in research expenditures, at least the last time I was able to gather these numbers, I think last year. Research computing, my organization, it's hard to put this into one sentence, but I would say that we accelerate the process of science by allowing people to solve bigger problems faster. We aim to reduce the time to discovery, and we do that by providing a bunch of different services that you can see on the bottom there. The usual suspects of advanced computing, VMs, cloud access, data storage, facilitation, engagement, all the human aspects as well. Specifically, some more detail, we've been around, research computing has been around since about 2005. We have our roots in the College of Engineering, but nowadays reside in the VPR's office. We have a faculty steering committee and a variety of staff positions, some of whom are on the call. Hey guys. And we provide a variety of computing services, everything from HPC, throughput computing, condo investment, HIPAA computing, and training and workshops. So what does it look like in terms of utilization? The last couple of years, we saw about 1,500 users that actually logged in and ran computations on one of our systems in the last 12 months. That's been about the average for a 12-month period. We deliver about 8 million core hours each month, and that has grown considerably since 2019 with increase in throughput computing and GPU computing in particular. Here's a quick video. I also cannot give a talk without talking about our new cluster. So we have a new system coming online. It's called SOL, and it was funded internally by ASU. We'll talk more about why this is important to OSG soon, but this is a video from back in January. We had Dell engineers on site installing some compute nodes, some CPU nodes, and notably, this is not a time lapse. They really do work this quickly. Dell gave us an express installation package to get these CPU nodes online. And these are in fact up and running now. The team has some compute nodes ready to go. Other aspects of the system still coming on board. No, we want to go to the next slide. There we go. So compute nodes there, you can see the end product. We've got some storage, we've got some VMs on the right, high performance parallel file system, liquid cooling. These pictures are just cool, so I wanted to show them of liquid cooled CPU racks that we've got deployed and up and running. All of that cooling loop is in place now, so we have that CPU capacity nearly ready to go. In addition to hardware, we also have engagement. We have an excellent research computing engagement staff. And over the last 12 months, we've had over 50 events with over 500 distinct attendees annually. And this comes in a lot of different forms, workshops, little classes, specifically on narrow topics, well, relatively narrow topics like R or Python visualization. We also are platinum members of software carpentry. We have several certified instructors on campus, including me. And we do regular weekly engagements, facilitation, meeting with each one of those 5,000 researchers. It's going to take a long time, but we're going to meet with all of them. And we also have a week-long research computing expo every summer. And we support classroom work as well, not just the research mission, but the learning mission, and that is growing quickly across many different domains. So what are we doing with OSG? Well, early our earliest effort was this, what I'm calling the OSG Pilot. And back in 2019, we spun up some gear that was old even then, some Dell M420s. And these are Sandy Bridge nodes that had 96 gigs of RAM each. And these are dedicated, these are just running OSG. These aren't HPC style nodes or anything like that. They're dedicated to OSG, really spun up as a project to see if we could do it and to see what it took to run this. So that was our first experience. And we've had some staff attend the summer school. I know some of my colleagues before me were talking about that as well. We've had a good experience having our staff learn the new best practices, how to spin up nodes and things like that. And that's become very valuable as we move on to newer projects. We have these 16 dedicated nodes still running in the basement of one of our buildings. We used to have 20, and they're kind of falling off as servers get old, things stop working. So that I would consider that pilot a success, but what else can we do? Can we do better? Can we do bigger? Can we innovate? Well, that system itself has contributed in the last, what, 2.5 years, 2 million core hours and 150,000 individual jobs. And this was from relatively low effort on our part. We spun these up and it's mostly fire and forget, keep them on, keep them connected, and they'll take care of the rest. We also have researchers at ASU using OSG themselves, and some of this does land on our dedicated nodes, and some of it lands out in the world. But we have at least most recently, we've had these 5 researchers that I list on the bottom using the system. ASU has consumed about 14 million wall hours, and run about 3.7 million jobs. And hopefully you can see that animated GIF. This is just one example of what one of those analyses looked like. Computational fluid dynamics simulation, leveraging the Pegasus workflow management platform on top of OSG to compute nearly 800,000 wall hours and over 440,000 individual jobs just for this analysis. 3 months of computation, and many visualizations, 3D visualizations were produced by this, and papers as well, publications too. I just show one in the corner there, but lots of great science coming out of ASU researchers using OSG. So now let's talk next about 2 different initiatives, 2 different grants that are leveraging OSG at ASU. The first one is an NSF CC Star. We've heard about this program a few times today, and we'll talk about that. And we'll also talk about an NSF CSSI grant as well that also has strong connection, strong utilization of OSG. So first is the Arizona Federated Open Computing Enclave, the A-Force. And yes, I thought of that name. So if you think it's cheesy, you can blame me. This is a 2021 CC Star grant, really emphasizing federated extramural computing access. That means that folks other than ASU researchers able to utilize this computing infrastructure that we're purchasing and deploying through the grant. There's 2 different ways we're doing that. One is through a collaboration of the Arizona Tri-University system. The other 2 public universities can log into the system we're looking at using Globosoft to make this relatively easy for them. That's the federated part. The advanced computing part comes in the form of the hardware. There we go. So similar to other folks talking about CC Star awards in the computing track, our plan was to purchase 10 dedicated GPU dense. So we're really emphasizing federated access to GPU computing, these GPU nodes, as well as 1,200 CPU cores. Ultimately, this would deliver 35 GPU devices, 200 of these high-end A100s, and 15 of the slightly lower spec A30s. And I say all of this in the present tense because we're not quite as far along as the folks you've heard from already today. All of this gear has been ordered, but supply chain and COVID and everything else has delayed the actual arrival of these GPU nodes. So these would plug into the Seoul cluster, the cluster we talked about earlier. This would be some of the GPU capacity that we're deploying there. Unfortunately, we don't actually have it yet. It is still in production at Dell and has not shipped yet. So this is what we plan to do. This is the idea, and I can show you what we're doing. To kind of turn this on its head. Just like other folks have said, we have a dedicated capacity going to OSG and other extramural research. And we're doing that just as one of the other presenters talked about, having a fixed number of dedicated nodes. These are our extramural nodes. It's an easy way to do this out of the gate. And we're doing this with OSG Glide-In running on top of Slurm. This will be a Slurm cluster running HPC style jobs and throughput computing jobs. When there is more than 20% available to extramural researchers, we'll contribute that as well. So no wasted cycles. At least that was the idea, but I just told you we don't have any hardware yet, right? But we do have this Soul cluster, all those CPU nodes we saw in the video. So what we're going to do in the meantime, while we wait for the GPU capacity to come in, we're going to configure the CPU nodes to do this so that we at least learn the software and configuration aspects of it. We'll still configure those NSF-funded nodes when they arrive. But in the meantime, we can at least work on the federated access part and the dedicated extramural capacity part. So we'll do that with CPUs first and GPUs when they arrive. In addition to that, those NSF-funded GPU nodes, these are the ASU-funded GPU nodes. And just like the NSF ones, these are also delayed. But that's 128 additional GPUs that will also be eventually contributing to OSG for extramural access to the ASU cluster. And in addition to that, all of that CPU capacity, the water-cooled stuff and all of that, that's about 15,000 cores, which again, when not in use locally, will be contributed globally. So we'll have that dedicated piece with the NSF-funded nodes eventually. And then we have this larger ASU-funded portion, at least the CPU aspects of which we have available now, and we'll contribute those. So here's the other project. This one's a mouthful, the Network for Computational Modeling in Social and Ecological Sciences Modeling Network, or COMSYS.net. And this is a NSF CSSI grant led by Michael Barton and the Complex Adaptive Systems Group at ASU. Some folks in research computing are also funded by this effort, including Jonathan Lee and Marisa Brazil, who I think are both on this call. So what are complex adaptive systems? Well, I am not the PI and the leader in this group, but I can tell you in basic terms that what we want to do is leverage analytic computational modeling and deep learning, machine learning, to model human behavior and technological behavior systems and nature. Now, any one of these by itself is plenty complicated, and modeling all three of them at the same time, we end up with very high dimensional parameter spaces for any kind of computational modeling we want to do here. And in addition to that, we need to model many different scenarios. What if nature does this? What if humans do that? Sometimes these things are unpredictable and stochastic, and we need to encapsulate all of that in a computational model. What does that mean? That means we need to run a whole bunch of models at the same time, and luckily they are independent. So what we have are these vast parameter sweeps that can run on CPU and GPU. And they're independent. We can run them all at the same time. We're limited only by the amount of computing capacity available to us. In addition to that, the way that Barton's group packages these models is through containerization. So I have a whole bunch of containers. I got to run them all at the same time and gain my insights in whatever time it takes to calculate all of them together. This is screaming for OSG, and in fact, that is exactly what they're doing. This effort will run these simulations on OSG. And how are we going to do that? Well, similar to what other folks were talking about, having open on demand, what we're doing in this project is what I'm calling an OSG Staging Server. That's not a great name, but this is, and this part of the project is part of a collaboration with Science Gateway's Community Institute. So we are not doing this entirely by ourselves. But the idea is to provide a server or a portal, a web presence that will allow you to build your containers, submit jobs like an old style submit server, and also stage and collect data. So kind of a one-stop shop for running these analyses, and bespoke, custom to the COMSYS domain. And that is a major software development aspect of the project. The other part of it is training. And this is the part that Marisa is involved in. We have those 50 trainings a year, right? included in that, or to be expanded in that, will be how to use this OSG staging service. So we'll have mandatory training to get in line to use this new thing that the ComSys folks are putting together. You come to our training, we show you how to use it, we show you how to build the containers, we tell you about what OSG is and how it works, and then we set you loose and you run your complex adaptive system models. All right, and that is everything I have for you today. So we talked about ASU's history with OSG, running some machines in the basement, to this new dedicated capacity coming in through NSF funding, and much larger opportunistic capacity coming in through central funding, all of which is dependent on supply chain, but we hope to have this up later this spring, supporting both those CC star efforts and the CSSI modeling effort. So thank you very much, and I'll stop sharing and invite any questions.
Thank you, Doug.
Doug, first of all, thank you for your presentation and all the work that you are doing down there. I'll say we would like to work with you and to turn your OSG staging server into what we call an access point.
Yes.
I would love to talk to you, and it may be a mega, meta, super, whatever you want to call it, but I feel that your vision of the staging server and what we have been presenting as an access point are aligned, and let's see if we can make it happen. So as I said, let's talk and see whether we can bring these two concepts together.
Excellent. That sounds great. Absolutely, Meron.
All right, we can take other questions in the chat or hands up. Carl, I'll call on you, and then I see at least one question in the chat.
Hello. So interesting talk, great talk. When you said the word extramural, it seemed weighted more than just OSG. Do you have other examples of extramural activities you're doing? Are you working with nonprofits? Are you working for commercial? And if so, do you have cost recovery with those? I'm interested.
Good question. For this, we do work with commercial, not specifically in this effort. The extramural right now, at least out of the gate, will be OSG and the other two public universities in Arizona. So that's the state level federated access part of it, where they can they can run grid style jobs, or they can log in and do Slurm style jobs. But right now, extramural at launch would be public universities in Arizona and OSG.
And it looks like the question that I saw in the chat was actually Carl's question, so it's already been asked. Other questions for Doug?
And to more clearly answer your question, Carl, we do have industry rates for using our service, and all the services from the first couple of slides, storage and compute and all of that. We do have rates for that. So if that were to show up and there were a use case there, we would leverage those rates. Obviously, we're not going to run commercial workloads on the NSF funded nodes, but on other capacity.
I will add here that I can see a scenario where our technologies are used to support such an activity, using what we can deploy, like what Frank presented with the compute access entry point, and it can be set aside for a commercial user or somebody else, and it can work in an autonomous private way, but use the same kind of tools. We have experienced it with Condor, that the same software that we are using to power the science side, for those of you who don't know, that since 2011, all the rendering of DreamWork was done under the control of HP Condor. So I feel that there is at least an option to use the technologies to create separate channels of bringing customers to your machine.
Excellent.
Any other questions for Doug? All right, well, thank you again, Doug, and to all of our speakers for this session.